So we need to find the three node voltages V1, V2, V3, and the current, this is I here, and this one is a current dependent voltage source. So what we can do by observation, we can first write few relations here. Is a super node here basically. So V2 can be written as V1 minus 25, and then V3 can be written as, this whole thing is a super node. So V3 can be written as, uh, we can treat this whole thing as one node. We have to do that. So V3 is V2 plus 4i, and V2 is V1 minus 25, and then we have, sorry, plus 5i, because this is 5i. So minus 25 plus 5i. Now 5i can be written as V1 over V1 is 2i, because V1 is actually dropped through this 2 ohms resistance and the current through this is I. So this one we have. So basically we are trying to write both V2 and V3 in terms of V1 and getting rid of the I as well. So V2 is, this one is becoming 5 there over 2 V1, because if I is V1 over 2, so 5i will be 5Vi over 2. So that's there. And then it can be, what here can be done is, if I multiply by 2, 2V3 is equal to 2V1 minus 50 plus 5Vi, V1, sorry. So this is V3 will be 7V1 minus 50 over 2. So that is the third relation. Now we can write KCL for this node, this big one. So we have this leaving current, this leaving current, and this leaving current, and this current is going this way, while we write the equation for V3 it will go this way. So these two currents will be in the opposite direction, so they will cancel each other, so we don't have to write that one anymore. This one and this one, we can just ignore these two, because even if we write them, V1, for this one we will write V1 minus V3 over 6, and for this one we will write V3 minus V1 over 6. So these two will get cancelled. So what we will do here is, V1 over, instead of, sorry, V1 over 2, V1 over 2 plus V2 over 4 plus V3 over 3. So these are the three currents, both all three are outgoing. And then if we multiply both sides by 12, 6V1, so this is 3V2 plus this one is 4V3, so that's 0. Now this one can be written as, this is 3V1 minus 25, and this is plus 4, 7V1 minus 50 over 2, like that, so that's 0. So 6V1 plus 3V1 minus 25 plus 14V1 minus 100, because this is getting 2 there and 14 minus 100. So then this one is, all these are added, so 23V1, and this will be minus 125, but going on the other side, so it's 1, actually this one will be 75, sorry, because 3 times 25 is 75, not 25. So this, the right hand side will be 175, 75 minus minus 75 minus 100, 170 going on the other side, so like that. So this one is 7.608 volts. Now we have that one, we can get V2 from V1 minus 25, so that's 7.608 minus 25, which is minus 17.39 volts, and then we can get V3 as well. V3 is 7V1 minus 50 over 2 there, so this one. So this is how we can find all three voltages. I am not calculating this anymore, but yeah, this even this one, for this one we didn't need to use determinant method for solving simultaneous equations. Because of the presence of the supernode and dependent source, we could write the voltages in terms of one voltage in terms of other one, so that's why it just became one equation in the end.